So next I am going to show you the assignment in collisions. I am going to show you 30 questions in this assignment based on one-dimensional collisions. Come on, look at the first question in the assignment. Two masses MA and MB moving with velocities VA bar and VB bar in opposite directions collide elastically. And after the collision, MA and MB move with velocities VB bar and VA bar respectively. The ratio MA by MB is. So I have shown 4 options on the screen. Come on, try the question. So in case you need more time to answer the question, you can take a pause and take your time. I am going to show the next question on the screen. Look at the question number 2. A body moving on a smooth horizontal floor makes a head-on elastic collision. The stationary body of mass 2.5 kg and then continues to move in its original direction with 1/4 of its initial velocity. The ratio of their speeds after the collision is. So I have shown 4 options on the screen here. Come on, try the question. So you can take a pause and take your own time to answer the question. I am going to show the next question on screen. See the question number 3. Consider the following statements A and B. Identify the correct choice in the given answers. Statement A. In a one-dimensional perfectly elastic collision between two bodies of equal masses, the bodies merely exchange their velocities after collision. Statement B. If a lighter body at rest suffers perfect elastic collision with a very heavy body moving with certain velocity, after collision both travel with same velocity. So you have to select one of the 4 options here. This question was given one of the previous MSET examinations in the MSET in medical, 2003 MSET medical. This question is based on the 2 special cases we have discussed in elastic one-dimensional collisions. In case you need more time to answer the question, you can take a pause and take your time. I am going to show the next question on screen. See the question number 4. In a one-dimensional elastic collision between two bodies of equal mass, first option velocities are interchanged. Second option linear moment are interchanged. Third option kinetic energies are interchanged. Fourth option all the above. Come on. Try to write your answer on the papers. Try to write all your answers on a separate sheet of paper. If possible, try to have OMR sheet, blank OMR sheet with you from your college. Or you can just get one copy of OMR sheet from your college and you can take it Xerox and so that you can practice on that. You can practice rounding off, blackening the bubbles, circles here, there. In case you need more time to answer the question, you can take a pause. I am going to show the next question on screen. See the question number 5. Steel ball of radius 2 centimeter is initially at rest on a horizontal frictionless surface. It is struck head-on by another steel ball of radius 4 centimeter, traveling with a velocity of 81 centimeter per second. Calculate the velocities of the two balls after collision. Assume the collision to be elastic. Come on, try the problem. You can take a pause and take your own time to solve this problem. This problem was given one of the very old IIT JEE exam papers long time in the past. But now this standard questions can be expected in other entrance, medical entrance and MSET and other entrance examinations also. Next, I am going to show you the next question on the screen. See the question number 6. A moving particle of mass m makes a head-on elastic collision with a particle of mass 2m, which is initially at rest. What fraction of the kinetic energy is lost by the colliding particle? Come on, try this question. This problem also comes under one of the special cases I have discussed in one-dimensional elastic collisions. In case you need more time to answer the question, you can take a pause and take your own time. I am going to show the next question on screen. See the question number 7. A neutron collides head-on and elastically with an atom of mass number A, which is initial at rest. The fraction of kinetic energy retained by the neutron is. We have shown 4 options in terms of the mass number A. Come on, try to answer this question. Almost all the first 10 questions are based on the one-dimensional elastic collisions, and most of these questions are based on special cases that are discussed in one-dimensional elastic collisions. In case you need more time to answer this question, you can take a pause and take your own time. I am going to show the next question on screen. See the question number 8. A sphere of mass small m moving with velocity of magnitude v, capital V, strikes a wall elastically moving toward the sphere with a velocity of magnitude u. The mass of the wall is infinitely large. The work done by the wall on the sphere during the collision will be. We are given 4 options here. Come on, try to answer the question. You can take a pause and take your own time to solve this problem. I am going to show you the next question on the screen. Question number 9. 6 identical balls are lined up in a straight frictionless groove made on a horizontal surface. 2 similar balls moving with speed v collide elastically with the row of 6 balls from the left. You are given 4 options on screen and you have to select the correct option. Come on, go through all the 4 options and try to write your answer on the paper. In case you need more time to answer the question, you can take a pause and take your own time. So in case you need more time, you take a pause and take your time. I am going to show the next question on screen. See the question number 10. Two identical blocks A and B, each of mass small m, resting on a smooth floor, are connected by a light spring of natural length L and the spring constant K, with the spring at its natural length. Third identical block C, mass m, moving its speed v, there should be small v here. Third identical block C, mass m, moving its speed v along the line joining A and B, collides elastically with A. The maximum compression spring is, you are given 4 options here. Come on, try this question. This question was given in the one of the previous MSET exam papers, in engineering paper. I think it was given in 2003 MSET engineering. Similar question was given in one of the very old IIT papers, actually. So you can take a pause and take your own time to try the problem. I am going to show the next question on the screen. So look at the question number 11. This is also based on similar discussion. I will read out the 11th question. Two bodies capital A and capital B of mass of small m and 2 small m respectively are placed on a smooth floor. They are connected by a spring. Third body C of mass m moves with a velocity v0 along the line joining A and B, collides elastically with A as shown in the figure. At certain instant of time t0 after collision, it is found that the instantaneous velocities of A and B are the same. Further, at this instant, the compression spring is found to be x0. Determine the spring constant. Come on, try the question. The procedure for solving this problem is similar to the procedure for the previous question, only for practice I have given one more question with a small difference. Here the masses A of two blocks A and B are not equal, that's the distinction. In case you need, probably you may need more time to answer the problem, you can take a pause and take your time. I am going to show you the next question on screen. See the question number 12. A ball of mass small m approaches a wall of mass capital M. Capital M is much greater than small m, with speed 4 meters per second along the normal to the wall. The speed of the wall is 1 meter per second towards the wall. The speed of the wall after elastic collision with the wall is. I have shown 4 options on the screen. First option 5 meters per second away from the wall. Second option 9 meters per second away from the wall. Third option 3 meters per second away from the wall. Fourth option 6 meters per second away from the wall. Come on, try the question. You can take a pause and take your own time to answer this question. I am going to show the next question on screen. See the question number 13. Block of mass m1 equal to 2 kg slides along a frictionless table with a speed of 10 meters per second. Directly in front of it and moving in the same direction is a block of mass m2 equal to 5 kg moving at 3 meters per second. An ideal massless spring of force constant K equal 1120 Newton per meter is attached to the backside of M2 as shown. The block collides. What is the maximum compression spring? Come on, try the question. So you can take a pause and take your own time to solve the problem. I am going to show you the next question on the screen. See the question number 14. A light particle moving horizontally with a speed of 12 meters per second strikes a very heavy block moving in the same direction at 10 meters per second. The collision is one-dimensional elastic. After the collision, the particle will. 4 options I am going to show you. First option, move at 2 meters per second in its original direction. Second option, move at 8 meters per second in its original direction. Third option, move at 8 meters per second opposite its original direction. Fourth option, move at 12 meters per second opposite its original direction. Come on, try the question. So in case you need more time to answer the question, you can take a pause and take your time. I am going to show the next question on the screen. Look at the question number 15. A ball of mass capital M moving with velocity v collides head-on completely inelastically. I will read out once again from beginning. Ball of mass capital M moving with velocity v collides head-on completely inelastically with another ball of same mass but moving in opposite direction with the same speed. After the collision, I am going to show you 4 options now. First option, the velocities are exchanged between the 2 balls. Second option, both the balls come to rest. Third option, both of them move at right angles to the original line of motion. Fourth option, one ball comes to rest, another ball travels with velocity 2v. Come on, try to answer the question. In case you need more time to answer the question, you can take a pause and take your own time. I am going to show the next question on screen. See the question number 16. A sphere capital A strikes with velocity u. Another identical sphere capital B at rest. The spheres A and B move with velocity 3v and 4v respectively after the collision. The question of restitution is, you are given 4 options on the screen. Come on, try the question. You may need more time to answer the question. In case you need more time to answer the question, take a pause and take your own time. I am going to show you the next question on screen. See the question number 17. In a one-dimensional collision between 2 identical particles A and B, B is stationary and A has momentum P. Again, I read out the question from beginning. A one-dimensional collision between 2 identical particles, capital A and capital B, is stationary and A has momentum small p before impact. During impact, capital A gives impulse capital J to capital B. The coefficient of restitution between capital A and capital B is, 4 options are shown on the screen. In terms of J and P, you have to find the correct option. Come on, try the question. This question was given in 2003 MSET, the medical entrance. So you may need, in case you need more time to answer the question, you can take a pause and take your own time. I am going to show you the next question on screen. See the question number 18. This question has statement 1 and statement 2. Of the 4 choices given after the statement, choose the one that best describes the two statements. Statement 1. A point particle of mass small m moving with speed v collides with stationary point particle of mass capital M. The maximum possible energy loss possible is given as small f into half small m into v square. Then small f equals small m by capital M plus small m. Statement 2. Maximum energy loss occurs when the particles get stuck together as a result of the collision. Come on, try the question. This question was originally given in IIT main exam 2013. That is a common entrance for NITs, admission to NITs and preliminary exam for, screening exam for IIT 2013. Come on, try the question. First, you check up whether the two statements are correct or not. Next, I will show you the options. In case you need more time to answer the question, you can take a pause and take your own time. I am going to show you the 4 multiple choice options for this question. You have to mark your answer as 1 if statement 1 is false, statement 2 is true. You have to mark your answer as 2 if statement 1 is true and statement 2 is true, but statement 2 and statement 2 is the correct explanation of statement 1. You have to mark your answer as 3 if statement 1 is true, statement 2 is true, statement 2 is not a correct explanation of statement 1. You have to mark your answer as 4 if statement 1 is true and statement 2 is false. In case you need more time to answer this question, you can take a pause and take your time. I am going to show you the next question on the screen. See the question number 19. Bullet of mass 50 gram moving horizontally strikes a wooden block of mass 950 grams, which is initially at rest on a rough horizontal floor. Nu equal to 0.25 means coefficient of friction between block and floor is 0.25 and gets embedded into the block. After the collision, the combined mass travels 5 meters along the floor. What was the initial speed of bullet? Come on, try the question. Come on, try the question here. I have shown 4 options on the screen. So after reading the question, you can take a pause and take your own time to answer the question. I am going to show the next question on the screen. See the question number 20. Ball falls vertically onto a floor with momentum small p and bounces repeatedly. That means small p the magnitude of momentum. The coefficient of restitution is small e. The total moment imparted by the ball to the floor is. 4 options I have shown on the screen in terms of P and E. This result I have discussed in one of the special cases in one-dimensional inelastic collisions in the earlier class, in one of the earlier classes. Come on. Try the question. This question was originally given one of the previous World IIT entrance exam papers. In case you need more time, you can take a pause. I am going to show you the next question on screen. See the question number 21. Ball 1 collides head-on. So again I read out, ball 1 collides head-on with an identical, with another identical ball to at rest on horizontal surface. For what value of coefficient of restitution E, the velocity of second ball becomes 3/2 times that of ball 1 after collision. 4 options are shown on the screen. Come on, try the question. So after reading the question, you can take a pause and take your own time to answer the question. I am going to show you the next question on screen. See the question number 22. Particle of mass m1 moves with speed v and collides head-on with a stationary particle of mass m2. The first particle continues to move the same direction if m1 by m2 is the question of restitution. First option equal to E, second option greater than E, third option less than E, fourth option greater than E square. Come on, try the question. So you can take a pause and take your own time to answer the question. I am going to show the next question on screen. See the question number 23. The bullet of mass 50 gram moving with velocity 500 meters per second passes through a wooden block of mass 1 kg. The block is resting on a smooth horizontal floor. After passing through the block, the velocity of the bullet is 200 meters per second. Its velocity related to the block is, 4 options are shown on screen. First option 215 meters per second. Second option 185 meters per second. Third option 165 meters per second. Fourth option 235 meters per second. Come on, try the question. So in case you need more time to answer the question, you can take a pause and take your own time. I am going to show the next question on screen. See the question number 24. A moving solid ball makes a head-on collision with a stationary ball. After collision, first ball comes to rest. 50% of kinetic energy lost in the collision. The question of restitution between the balls is, you are shown 4 options on the screen. So after reading the question, you can take a pause and take your own time to answer the question. I am going to show you the next question on screen. See the question number 25. Bullet of mass 0.01 kg and traveling at a speed of 500 meter per second strikes a block of 2 kg which is suspended by a string of length 5 meter. The center of gravity of the block is found to rise a vertical distance of 0.1 meter. What is the speed of the bullet after it emerges from the block? Come on, try the question. You have shown 4 options on the screen. So after reading the question, you can take a pause and take your own time to answer the question. A sphere capital A impinges directly on identical sphere B at rest. Directly means head on. That means one diameter collision. Here the question of restitution. Find the ratio of velocity of A and B after the impact. Come on, try the question. Your answers should be expressed in terms of the question of restitution E. You are not shown multiple choice options here. After reading the question, you can take a pause and take your own time to answer the question. I am going to show the next question on screen. See the question number 27. A ball is released from the roof of a building 5 meter high. It bounces back from the floor and rises to a height less than 5 meters. Then bounces again from the floor, rising back in the same proportion. The total vertical distance traveled with the ball before it finally comes to rest, 45 meters. Calculate the coefficient of restitution between the ball and the floor. Come on, try the question. This problem comes under the special case which I have discussed in one complete case. This one dropping of a ball from certain height on the floor. If you remember the conclusion I have discussed, you can directly use the conclusion to solve the problem. So after reading the question, you can take a pause and take your own time to answer the question. So I am going to show you the next question on screen. See the question number 28. A 5 kg body moving with a speed of 10 meter per second collides head on with a 2 kg body moving in the same direction with a speed of 5 meter per second. After the impact, the 2 kg body acquires a speed of 12 meter per second. Find the coefficient of restitution. Come on, try the question. So after reading the question, you can take a pause and take your own time to answer the question. I am going to show you the next question on screen. See the question number 29. 3 particles each of mass small m moving with equal speeds along the medians of an equilateral triangle on a smooth horizontal plane collide at the centroid of the triangle. After collision, capital A comes to rest and capital B retraces its path with speed v. The speed of C after collision is, 4 options are shown on the screen. First option 0, second option v by 2, third option v, fourth option 4v. Come on, try to answer the question. So in case you need more time to answer the question, you can take a pause and take your time to try the problem. So I am going to show you the next question on the screen. So this question is of course not based on one-dimensional collision, but based on conservational linear momentum. All the other questions in this assignment are based on one-dimensional collisions. See the question number 30. The last question in this today's class, in this assignment. Pendulum bob of mass 10 power minus 2 kg is raised to a vertical height of 5 into 10 power minus 2 meter and then released. The bottom of its swing picks up a mass of 2.5 into 10 power minus 3 kg. To what height will the combined mass rise? That means you have to assume that the bob is released, pull it to a side, away from the vertical, and released from rest. From height h equal to 5 into 10 power minus 2 meters. The bottom it collides with another particle of different mass m2, and both the particles move together after the collision. So you have to find the, this is only a imaginary horizontal line I have drawn, it should not be mistaken as a floor here. You have to find the maximum vertical height to which the combined mass rises above its lowest position after collision. So after reading the question, you take a pause and take your own time to try the question. I am going to show you the answers for all these 30 questions, so that first you check up your working, that means check up all your answers. But I will not be discussing the solutions of these questions in this class. I will be discussing the solutions of these questions in my next class. Now I am going to show you the answers for all the 30 questions one after another. Come on, look at the screen for answers. First I have shown the answers for the first 10 questions on the screen. For question number 1, answer is 3. For question number 2, second option is answer. For question number 3, third option is answer. For question number 4, fourth option is answer. For question number 5, you get answers as V1 equal to 63 centimeter per second and V2 equal to 144 centimeter per second. For question number 6, answer is 8 by 9. For question number 7, second option is answer. For question number 8, third option is answer. For question number 9, second option is answer. For question number 10, first option is answer. Next, for question number, next I have shown the answers from 11 onwards. So look at the answers for the questions numbering from 11 to 20. For question number 11, answer is K is equal to 2m V naught square by 3x naught square. For 12th question, fourth option is answer. For 13th question, you get maximum compression spring as x equal to 0.25 meters. For next 3 questions, 14, 15 and 16, second option is answer. For next 3 questions, 17, 18 and 19, first option is answer. For question number 20, fourth option is answer. In case you need more time to copy the answers, you can take a pause. Next, I am going to show you the answers for questions numbering from 21 to 28. For question number 21, first option is answer. Next 3 questions, 22, 23 and next 4 questions, 22 to 25. Second option is answer. For question number 26, you get ratio the magnitude of velocities after collision, V1 by V2 equal to 1 minus E by 1 plus E. For question number 26, answer is 2 by root 5, that is question of restitution. For question number 26, you get the answer as 0.96. For question number 27, third option is answer. For question number 28, answer is 3.2 in 10 power minus 2 meter. Next, I am going to show the answer for next two questions. I mean on numbering order. This is 22, 23, 24, 25, 26. Here it is the 27th one, and this is 28 answer, and this is the 29th question. Answer option is 3. And for question number 30, you get answer at 3.2 in 10 power minus 2 meter. Please correct that. We copy the answers and take up your answers. In case you need more time to copy the answers, you can take a pause and take your own time. In my next class, I will be discussing the solutions of all these questions. So some of you may not have any doubts in the first 10 questions. Therefore, in case you don't have any doubts in the first 7 or 8 questions, you can skip my next class, which I am going to solutions of the first 7 or 8 questions or maximum 10 questions.